Hello, my name is Faisal and my IT number is IT22353498. So I did the OpenID Connect and also fixed the vulnerability, the plain text password storage. So when it's come to this OpenID, it is a completely a new feature to this project which we didn't had previously. So the user can sign up and sign in using their Google account. If the user signing without a registered account, it will pop up and message to register. So they can register using the form or using through the Google account. Once the registration is successful, it will redirect to the home page and user can navigate and buy products. And this is the implementation for this Google code for the both sign up and sign in. Secondly, I fixed the crucial vulnerability where passwords were stored in plain text in our database. So now during the registration, password were hashed using the bycrypt library and also before being saved, and during the login we verify the provided password against the stored hash on the server. Because only the hashed value is stored, an attacker who gains access to the database can no longer read or reuse user's raw password. So this is the implementation. I did it for the employee login and also for the delivery and also for the customer, where now the password are hashed and stored in the database where the attacker can no longer see in the plain text passwords. Thank you.
Hello, I'm Mohammed Shadir Fauz, and my IT number is IT triple two 37118. And I have selected two vulnerabilities, and one of them, which are information disclosure vulnerability, and the other vulnerability is the cryptographic failures. And when it comes to the information disclosure, it is mainly happen due to these improper error handling of requests. So for that, I have binded, especially for the customers. So I have handled the errors using proper status codes, and along with that passing a meaningful message, so that it will be easier uh, for the server to identify the server codes and respond responses. And when it comes to the next vulnerability, it is the cryptographical failures, and it is mainly happened due to uh, session hijacking. So for that, I have used storing of session cookies along with the login functionality. And whenever a custom logs into the system, a session will be assigned for him in order to store his own details, like username, uh, passwords, and any other relevant uh, unique informations, which are unique for the person. And this will be stored inside the browser, and these cookie sessions are uh, mostly used in every actually used in every request in order to send them along with that, so that it will allow the system to identify in each request whether the authorized person is allowed to uh, do those respective functionalities. And when it comes to the logout functionality, again the assigned session will be cleared over here so that no one else's would handle these get that sessions back again, and this can be showed using the login functionality. And whenever a user log out, it will be redirected to sign in page. And even though the he can go back, he isn't allowed to do any other functionalities in the page. And that's it. Yeah.
Hello everyone, my name is Shukri. My IT number is IT 220 5224. Today I'm going to demonstrate two critical vulnerabilities I found in a previous project and how I fixed them. The first was a broken access control, which is currently number one on a OSP top 10 list. Sensitive customers' data was exposed because there are no authentication or authorization checks. In our new implementation, I added a multi-layer security approach. First of all, authentication middleware that verifies every request with a valid JWT token. And the second one is authorization middleware ensures that only the allowed roles can be accessed the sensitive data. In this endpoint, only admin can access this endpoint. I'll show a demonstration. This is a customer login. This is JWT token as defined as role as a customer is unauthorized for this endpoint. The employee login with the admin role. This return all the sensitive data because authorized only for admin. And my second vulnerability defined as a brute force login attacks which falls under OSP identification authentication failures. Originally, attacker could make unlimited login attempts without restriction. To fix this, I implemented rate limiting after 5 failed login attempts within 15 minutes. Further requests are blocked with a 4 to 9 too many request response. I'll show a demonstration. And this is a invalid password. After 5 attempts, it shows too many login attempt. Please try again. This is a successful implementation of the rate limiting. And thank you.
Hello everyone, my name is Mohammed Mufiz. My IT number is IT 22320896. I have found two vulnerabilities. One is security misconfiguration, and another one is NoSQL injection. Uh, First, we move to security misconfiguration. When someone uploads an image, it was checking only the image type. That means it's whether PNG or JPEG, but it doesn't check whether it's a real PNG or JPEG. That means an attacker can change the attacking file format to PNG and upload it, but it was not catching that. So that I have added the magic numbers, so it will check the magic numbers also. Uh, if it is the real PNG, only the magic number will be correct. Wait, I will demonstrate it. This is the file with the attacking code, but I have changed it to PNG. When we upload it, it will give an error so that it is catching the attacking file. Then the other one is NoSQL injection. Here, when the I mean, when we submit an object, when we create something, it will check for NoSQL injections. If the parameter has this symbol or the dot operator, it will catch. Here we are using the sanitize part for every request. Here, when we create a supplier with the correct body, it will create. But when we create with the NoSQL injection, it will give you an error because we have this NoSQL injection part. Thank you.